everybody and welcome back to another video. In this video I will be covering the derivative of y is equal to sine of x to the cosine x with respect to x. So for this equation we have a variable in the base and in the exponent. So we are going to use something called logarithmic differentiation to solve this problem. So let's start by rewriting our problem down here. So we have y is equal to, let's leave some space because I'm going to do something over here, sine of x to the cosine of x. So now we are going to take the natural log of both sides. So when we take the natural log of this side and the natural log of this side, we can bring this down due to our exponent rules for logarithms, where if you take the log of a to the b, that is equal to b times log of a. So when we bring this down, we get ln of y is equal to cosine of x times ln of sine of x. And this has a bracket. Now, we are going to differentiate both sides. So d over dx, d over dx, and we're going to need a product rule here as you can see, but first let's start off with this side. So this is going to actually be an implicit differentiation of y as well as a chain rule. So this becomes 1 divided by y times the derivative of the inside, because that's a derivative of ln of x, times the derivative of the inside, which is dy over dx, which is what we are looking for. And that is equal to this side. Now let's start. So this is going to be a product rule question. So if you take the derivative of f of x times g of x, that is equal to f prime of x times g of x plus f of x times g prime of x. Now when we apply this here, we can take the derivative of cosine of x with respect to x, which is negative sine of x, and multiply that just by the ln of sine of x, which is by itself, so it's times ln of sine of x. Now, we are going to add the cosine x, and now we're going to multiply that by the derivative of ln of sine of x. So the derivative of ln of sine of x, this is just another chain rule. So we are going to do 1 divided by sine of x, as that is the derivative of our ln of u, and multiply it by the derivative of the inside, which is just going to be cosine of x. So this is cosine x divided by sine of x, which is also just cotangent to x. So now this is cosine x times cotangent to x. So we have our derivative on this side. Now we are going to multiply both sides by y to get dy by dx by itself. Now these y's cancel and we get dy over dx is equal to, let's write out this term, let's rearrange these so that way we have the positive first and then the negative sign second. So we have cosine x times cotangent of x minus sine minus we'll just leave this sign on the outside, minus sine ln of sine of x. And now we are going to multiply that by y, because we had to for the previous step. And if you recall, y is just equal to sine of x to the cosine x. So this is all multiplied by sine x to the cosine x. And this is dy by dx. This is our answer. So our final answer is this right here. Dy over dx is equal to, in brackets, cosine x times cotangent x minus sine times ln of sine of x, all times sine of x to the cosine x. So I hope you all enjoyed this video. I hope you learned a lot. This is an incredibly difficult derivative for logarithmic differentiation. And if this video I'll say if this video could get to 3,000 likes, I will do an over an hour long derivative on YouTube.